Hey guys, so in this problem, I'm trying to figure out what the voltage at VA should be. You can see that we've got two sources in this problem, and one of the methods that we know about uh, where we can solve for uh, quantities in problems that have multiple sources is superposition. That's basically where we're going to solve the problem once for each source, and then we're going to overlay all the results. So let's do this. I want to know what is the voltage at this spot right here. So I'm going to have to solve this once with the current source in and the voltage source out, and then another time with the voltage source in and the current source out. So let's do the current source first. So here it is. It's 120 milliamps, which is 0.12 amps. And we've got a 1.7K resistor right here. And then we've got this resistor, which is 980. Here is VA, 470. Okay, so how do we turn off a voltage source? We short it. If it's a voltage source and we want to zero it, we short it. If it's a current source and we want to zero it, we open it. Okay, so let's look at what's going on in this circuit. Well, we know that the current is flowing like this. You can see this current source is pulling current down that way. So we're going to have some current going like this, and we're going to have some current going like this. And so our voltage drops are going to be from here to here, here to here, here to here, and then again here to here. But if I knew this drop right here or this drop, then I would know VA due to the current source. So I think what I'm going to do is I'm going to do current division. Well, I know that this current right here, I'm going to call it IT. See how this current and this current meet together right there, and they all flow out like that. So I already know what IT is. It's telling me it's 0.12 amps. So basically 0.12 amps is being divided between this branch and this branch. So let's use two branch current division to figure out how much current is going through, say, the 330. Well, we take the current that's being divided, that's 0.12 amps. Sorry, I'm still writing in pink there. 0.12 amps times, now with two branch current division, in the numerator goes the branch that you're not looking at. So that's this one. And then in the denominator, it's the sum of both branches. So it's 470 plus 330. And that's going to tell me this current right here. So let's figure it out. So we've got 0.12 amps times 470 divided by 470 plus 330. And that is 70.5 milliamps. So that means 70.5 milliamps is flowing that way. Well, what's the drop across the 330? We just take that current and multiply it by 330, and it's going to be 23.26 volts. So from here, which is 0 volts, to here, there's a drop of 23.26 volts. So that means that this spot is minus 23.26 volts due to the current source. Okay, well, now we need to know what the voltage source is contributing to this. So I need to remove the current source. How do I do that? I open it. All right, well, that cuts off this whole leg of the circuit right there. And there's no current flowing through the 980. Here's the 470. Here's our 50 volt source. Here's the 330. All right, now let's look at what the current is doing. It's leaving the voltage source, right? And it flows into this node. Does any of it go to the left? No, because there's no path for that current. So all of it just continues on to the right, like this. All right, well, if I knew the drop across the 330 right there, then I could know what VA is. So VA is equal to 50 volts. That's this voltage right here. It's being divided by these two resistors. So the thing I'm looking for the voltage across is the 330. So that goes in the numerator. And then in the denominator, it's going to be 470 plus 330. Let's see what VA should be. So we've got 50 volts times 330 divided by 330 plus 470. That is 20.62 volts. Okay. Volts. So the results add algebraically. So due to the current source, we've got minus 23.26 volts right here. So minus 23.26 volts. And due to the voltage source, we've got 20.62 volts. So when we add them together, that is the real voltage at VA. So let's do that. So we have minus 23.26 plus 20.62. We've got minus 2.64 volts. So that's the voltage at VA right there. Sorry, my paper tilted. So I just used the superposition principle to solve for that voltage in this circuit where we have multiple sources. And that's it for this one.